Welcome. In this general chemistry tutorial, we'll look at balancing redox equations with the half reaction method. Here we'll balance the following redox reaction in acid by half reaction method. Our first step is to separate those into two half reactions. We then want to balance the redox atoms. Typically, the redox atoms will be anything other than oxygen or hydrogen. To make sure that they're balanced, we have one manganese on each side of the equation, as well as one bismuth. We then balance by adding water to account for the number of oxygens. Since we have 4 oxygen in the first half reaction, we add 4 water. In the second half reaction, we have 3 oxygen, so we add 3 waters. Now we balance the hydrogen by adding H+. 4 times 2 gives us 8 hydrogen atoms, so we add 8 H+. We'll add 6 H+ to the other half reaction. Now we need to balance the electrons. The charge gets balanced by adding the number of electrons. Let's look at the total charge on each side of the equation. The manganese ion gives us +2 on the reactant side. Permanganate is -1 plus the +8, so we have a +7. We're going to add the electrons to the more positive side, so we need to add up to +2. We add 5 electrons. In the second half reaction, we have a +5 and a +3. So the electrons are going to be on the opposite side of the equation. We're going to add 2 electrons to the reactant side. This should now balance the charge to +3 on each side for the bismuth half reaction. All right, our next step is to balance the number of electrons. So since we have 5 and 2, we need to add up to a total of 10 electrons. The number of electrons being transferred has to be equal. So we multiply the first half reaction by 2 and the second half reaction by 5. That gives us the following half reactions. Our next step is to simplify and combine. The number of electrons, 10 in this case, since they're equal and on opposite sides of the equation, they can cancel each other out. So in our final reaction, we do not see any electrons. We can also simplify the number of water. If you have the same thing on opposite sides, just subtract. So we have 7 water left on the product side. We can also simplify the number of hydrogen ions. We're left with 14 on the reactant side. Let's go ahead and add these reactions together, and this should be our final balanced redox reaction in acid. 14H plus 2 Mn2 plus 5 BiO3 yields 2 MnO4 plus 5 Bi3 plus 7 water. A balanced redox reaction will be balanced with the number of atoms on each side of the equation, as well as the total charge on each side of the equation. if we were to look at this reaction and balance it in base, what we could do is follow the rules and balance it as if it were acidic, and then convert it to basic conditions. So we take that same balanced equation that we had previously, and to convert it to base, we're going to add hydroxide to both sides of the equation. How many hydroxides do we add? Well, we want to get rid of all of the hydrogen ions, so we're going to add 14 hydroxide, and we do that to both sides of the equation. Well, the hydrogen ion and the hydroxide will make water. So now we have 14 water, which can then be simplified because we have originally 7 water on the product side, right? So we've simplified, we'll rewrite the equation. So it looks like water has flip sides, and now we have hydroxide. So we've balanced the redox reaction in base.